All right, again, happy Friday. Okay, so if we look at number 6, what is that? First of all, I want to see what is the highest power. So the two things I want to look for. What's the highest power? And get the name for that. What's the highest power of the variable? And then how many terms do I have? And that's the second thing I'm going to call it. So the first thing is there is no power. There is no variable. So if I have no variable, that means the degree is 0 because there's no the x to the 0. It's a constant. And it's one term, so it's a monomial. So this is a constant monomial. Mister, why don't you write on the line? Oh, because I want to put it right next to it. Okay, next, number 7. Third power. So that means that it is a cubic. And then I have 1, 2, 3, 4. So 4 terms. There really isn't a term for 4, so we just call it a polynomial. I can't spell. Polynomial. There you go. Nice. All right, this is how we celebrate, right? Because this is how we feel, right? I don't think you heard that. Let's do that again. There you go. That's the horn we feel like today, right? All right, so we look here. This looks familiar because we've been graphing things like this. That's a quadratic. It's a quadratic, and it has 1, 2, 3 terms. It's a quadratic trinomial. Quadratic trinomial. Some of you are feeling like this. That's okay. It's okay. All right, number 9, fourth power. Those of you like, I forgot what that was. Just go over here. Quartic. That's a quartic. And there's only one term. There's no plus or minus anything. It's only one term. Quartic monomial. Quartic monomial. And now 10 and 11 is now you do this higher thinking, right? Yes, it's quartic. It's to the fourth power. Right? Monomial. Quadratic would be to the second power. And so, number 10 and 11, can you give me your example? So someone give me an example of a cubic binomial. 11x cubed minus 2x. Bam. That's one. Anyone else? Any other example? Come on, chat. Come on, chat. We were having, I was with you. Oh, there we go. We got one. 10x cubed minus 5x. That works. We have 5x cubed plus x squared. Good job. So all we have to do is find one that's to the third power, your highest exponent, and then 2 terms. All right, one more and we'll go on to the next one. Come on, give me one more. Somebody that hasn't spoken yet. Come on. Dance with that fear, guys. Don't be, okay. Again, I was going to say it. Yes, go ahead and be afraid, but dance with that fear. I got to get that out of my vocabulary. Don't be afraid. Nobody wants to do one more? All right. What about a linear monomial? A linear monomial. Oh, wait, someone did it. So someone said 7x cubed plus 9x. That's good. Let's go. All right, so linear monomial. Negative 3x to the first power. You can put the first. You don't have to. There you go. We have 5x. And you can just put 5x. You don't have to put to the first. If you just put x, we all know it's to the first power. So 5x. Yep. So this one's pretty easy. Just get one more. Let someone give me a complicated one. No? How do you get complicated? 500x. Okay, we'll take that. It's a big number. What about something like this? 251 over 983x. 1/4 x. I see that. Good job. Good job. All right. So we got this. We got this. All right. So now that we know what polynomials are, now that we can name them, right? Now that we can put them in standard form, we can put them in order in either descending or ascending order. Descending from highest to lowest is the way we usually do it. Now let's add and subtract them. You've been doing this already. You've been doing this since 5th grade, right? And the key word to adding polynomials is combining like terms. That's it. You look at your polynomials, you put all the, it's like if you have a whole bunch of fruit on a table, right? What is our nature? What do we want to do? If you're sitting at a table and there's just a bunch of fruit in front of you, what's the first thing you want to do? Like there's grapes and bananas and oranges and grapefruit and apples. Put them in groups. That's exactly, it's like human nature. Like if you came into class and I threw a bunch of cubes. Oh, I don't have my cubes with me. Just a bunch of different colored cubes in front of you. You'd want to put the reds with the reds, the blues with the blues, or the apples with the apples, the bananas with the bananas, the pears with the pears. That's just nature for us to put them in groups. So the same thing here. So, but the problem that some students have is they don't know what groups with what combines with what. So combining like terms, well, what's a like term? A like term are terms. So if we're right here, like terms, and it's not someone from the 80s saying, oh my God, it's like terms, like, you know, like totally terms. Not like that. Like terms just means terms that have the same variable with, and it has to be with, the same exponent, right? So if you see an x and an x, those are like terms. If you see an x squared and an x cubed, not like terms, because one is to the second power, one's to the third power. They have to have the same exponent. And that's it. Combine like terms, and make sure you look at the sign. Make sure you look at the sign in front. And if we're combining or adding or subtracting polynomials, remember I told you the polynomials, spam risk. Polynomials sometimes are put in parentheses because a polynomial, you have to think of, sometimes a polynomial represents a thing, one thing. Even though it has like multiple terms, it still represents one thing. It's put in parentheses. So the first thing it says right here is don't forget to distribute the negative. So if there's a minus outside that group polynomial, you got to distribute the negative before you combine. Really simple. So if I look here at number 1, and then write your answer in standard form. If you don't write it in standard form, you're not going to lose points or anything, but it's just like I said, it's just a convention, just to keep things organized, to keep it in standard form. Okay. So if we look at number 1, this polynomial, I don't need the parentheses. The parentheses is just there because this problem probably represents, I'm adding 2 things, right? I don't know if you notice, it looks like it's 6 things, but I'm kind of adding 2 things. I'm adding a trinomial to a trinomial. And that first trinomial in parentheses may represent something in a real life problem. Okay, so that's why we group them. Like, Mister, why do we group them? What's the whole point of that? Because a polynomial may represent one entity, one thing. Okay, so but when we're doing math, when we actually put it down, we don't need the parentheses, so we can try to get rid of them. So if I look at the first polynomial, there's nothing in front of the parentheses, so I can just get rid of the parentheses. And then the second polynomial, there's a plus in front of it. So if I distribute a plus, it doesn't make sense because everything just stays the same. So plus negative 5x would just be minus 5x. Plus x squared would just be plus x squared. And plus negative 13 will be minus 13. Everything just stayed the same. And now we combine our like terms. And the way I like to combine my like terms, it's just organization, just stay organized. And just start from the highest exponent so we can keep this in standard form. Just start with combine the highest exponents together first, then the next highest, and then the last thing you combine are the numbers. So the first thing is I see an x squared here and an x squared here. So 3x squared plus x squared, just add the coefficients. Mister, what are the coefficients? Add the numbers in front of the variables. So that's a 3 and that's a 1. If you don't see a number, it's a 1. So 3x squared plus 1x squared is 4x squared. Now let's look at the x to the first power, 11x minus 5x. So 11 minus 5 is plus 6x. And then the last one, positive 4 minus 13. So 4 minus 13 is negative 9. And there you go. I combine like terms, and it is in standard form. Highest exponent to lowest. Easy? Too easy, right? Do I need to go over more? Should I go over a subtraction? Do you need time to copy this? Again, silence. It's funny. I get so many comments from you guys and interaction. Yeah, I'll give you time to copy. It's just funny how I get so much interaction, so much stuff from when we talk about stuff that's not not algebra 2. And then as soon as I get to the algebra 2, it's like silence for the most part. There's nothing to solve. Exactly. There's nothing to solve because there's no equal sign. Right? This is just expressions. These are just expressions. Right? If there's an equal sign, then there's some solving, right? But since there's no equal sign, all we're doing is combining the terms, and there's nothing else to do because we have no idea what this equals. We just had two polynomials and we grouped them together. Yeah, that's one of the biggest confusions with most math students. Like they think they have to solve everything, right? And if there is no equal sign, that's a huge clue, right? That's a huge, where is it? Where is it? Oh, there it is. Right. That's a big alarm in your brain saying, oh, there's no equal sign. Don't need to solve anything. I'm just simplifying. All right, let's try number 3. I want to try number 3 because it has a minus. So number 3, I have this polynomial. And there's nothing in front of the group, so I don't need those parentheses. 5k cubed minus 2k squared plus 2k. And now we look at the second polynomial. It's in parentheses, so it's grouped together. So this trinomial, this quadratic trinomial. And since I have a minus in front of it, I need to distribute that minus. And so minus 2k squared minus 2k minus 17. And so now I look at what's the highest exponent. Ooh, right here, 5k to the third power. All the other ones, nope, no more third power, so that's my first term. Next is second power, so I see minus 2k squared and minus 2k squared. So what's negative 2k squared minus 2k squared? Yes, always be careful when there's a negative or subtraction, exactly. So I have negative 2k squared minus 2k squared. That's minus 4k squared. Okay, next we look for the k to the first. So I have 2k minus 2k. Ooh, 2k minus 2k. That's 0. That's 0. And then lastly, I have one constant, minus 17, so it's minus 17. It is that simple. Are there any questions to adding, subtracting polynomials? You guys have been doing this for a while now. You just didn't have names for the polynomials and the degrees. But you've been combining like terms for a while now, right? Any questions? Any questions? Now the multiplication is where it becomes fun. Oh my God, it's 11:36 already. So here's what we're gonna do. I'm gonna make the homework due Monday night. Is that okay? You can start it this weekend, but I'm gonna have the homework be due Monday night. So that way all Monday we can go over it and talk about it. Because so I believe this weekend you can do the adding and subtracting parts of the homework. And you possibly can do the multiplying. I mean, we've been doing it first semester. It's just kind of a review. This is all review. Okay. And no questions about adding and subtracting? Going once. Going twice. It's okay to be afraid to ask. Someone said wait. Ooh, okay, I'll wait. Yes, you want me to zoom in on 3 or 1, or is this fine like this? So you can see both of them. Okay. Mister, you're going too fast. Calm down. Okay. Sorry about that. Sorry about that. Quiz when? Probably next week. I'm thinking next Friday or Thursday we'll have a quiz on adding, subtracting, multiplying. So that's what the first quiz is going to be. Adding, subtracting, multiplying. That's it. Just a quick quiz. Maybe even Wednesday. See how well we do this. Okay. All right. Multiplying. There's some controversy here. So I can have a polynomial times a polynomial. So here's how it works. So I have a polynomial times a polynomial, right? So basically, if I want to multiply a polynomial times a polynomial, everything in here needs to multiply with everything in here. That's how it works. And then you'll see some math books and some teachers, maybe your Algebra 1 teacher taught you something called FOIL, right? Did your teacher teach you that? Did your teacher tell you that FOIL has limits? I hate FOIL, by the way. I love FOIL to wrap food, right? Wait, how are you saying no? Rosalind, how are you saying no? I taught you this. Actually, no, I didn't. Look, I hate FOIL. I'll still teach it to you, right? Just because I don't like teachers who don't like something. So like, oh, I don't like this, so I'm not going to teach you. Of course I'm going to teach it to you. It's a classic thing. You'll see it. You'll see it in math books, FOIL. The reason, and I'll give you the reason, right? Because I can't just tell you something. You can't just hate something. Tell me why. Right? I got to tell you why I hate it. FOIL only works for binomial times a binomial. It only works for a binomial times a binomial. And so that's why I don't like it. Now, does it work? Sure. So if you have x plus 7 times x plus 3, FOIL works perfectly. And let me explain what FOIL means. FOIL is just the order, because everything here, in here, all two things in here have to multiply with all two things in here. And so FOIL is just an organized way of doing that. First terms, so multiply the first terms. So x times x. Next, multiply the, what's O? O is outer terms. So x times 3, or 3 times x. And then you do the inside terms. That's E, or they say inner terms. So that's plus 7 times x. And then the L is for the last terms. Multiply the last terms. Plus 7 times 3. Okay. And then you just do this. So what's x times x? X squared. What's 3x plus 7x? Plus 10x. What's 7 times 3? Plus 21. And there you go. Plus what?
21.
Yes, plus 21. Okay. FOIL works, but again, it only works for binomial times binomial. I don't like this because I like to use tools that work for multiple things, right? I like to use tools that work for multiple things. So this works, and it works good on binomial times binomial. Okay. But if I look at number 6 right here, see number 6, the example 6? Here is a binomial, but this is a trinomial. FOIL will not work. FOIL will not work. So there's two other options. There's two other options that will work for everything. Okay. And one of them is just use the distributive property. Okay. This one's okay. I'm okay with this, but I think this gets a little sloppy. Okay, I'm going to show you my favorite method in a minute. Well, I think I may have to show you my favorite method Monday because we have 4 minutes left. But distributive method just says, get this first term in here and multiply it to everything over there. Distribute it to all those terms over there. So w times w squared plus w times 2w plus w times 1. And then I get the second term in here and I multiply it to everything over there. So I get minus 7 times w squared, right, because it's negative 7. And then minus 7 times 2w, and then minus 7 times 1, right? And then you work all this out, and you w times w squared is w cubed, w times 2w is 2w squared, w times 1 is 1w, negative 7 times w squared is negative 7w squared, negative 7 times 2w is negative 14w, and negative 7 times 1 is minus 7. So then now we combine some like terms. Here's the first one, w cubed. Then there's my squareds. 2 minus 7 is minus 5w squared. Then we have w minus 14w. So 1w minus 14w is minus 13w. And then there's my constant minus 7. And there you go. That's the distributive property, right? You just distribute each term in the first polynomial to every term in the second polynomial. Then you get the second term and multiply that to every term. And you can do that, and this works for all polynomial multiplication. So it's a good method. It's a good method, but the one bad thing about this is it can get sloppy. If I have a trinomial times a trinomial, I'll have a longer list of things to put together. If it's a 4-term polynomial times a 5-term polynomial, then I have a big long list of things to do. Okay, so on Monday, I'm going to teach you my favorite way, and I think it's the most organized way to multiply any polynomial times any polynomial. It's very organized, doesn't get very messy, and it works for everything. And if you want to look it up this weekend, it does say right here, it's called the box method or the area model. Okay, so I've shown you FOIL, but that only works for binomial times binomial. I've shown you distributive property where everything, one at a time, you distribute to everything in the other polynomial. That works for everything, but it can get messy if you have larger polynomials. And the third way, which I'm going to show you Monday, so stay tuned and tune in on Monday for me to show you the box method or the area model. And you can look that up yourself this weekend if you want to. So start the homework. Homework's not due until Monday night. I will change the due date on Schoology. And time is up. Have a great weekend. Go look into do some research on some stocks, and we'll start talking about that on Monday too, and how to invest and all that good stuff, and what it all means. And the journey is going to be with me too, because my knowledge of it is not that vast. So we will learn together. So everyone, take care. Start your homework this weekend. Don't wait till Monday to do all of it. Start some of it now, the ones you can do. And take care, guys. I'll see you on Monday. Have a great weekend. Bye, Mr. Davila. Thank you for your help.
Thank you, Mr. Principal. You're welcome. Have a good day.
You too. Oh, you did it already. Good job. If you finished the homework, great. Then you have nothing to worry about. All right. Take care, guys. Have a great weekend. We will be your first audience.